Yeah, so welcome to another uh, series of EPEVER webinars. And thank you so much for being with us today. And it's my pleasure to talk a little bit about inverters and especially iPower series today. So far, we were most concentrated on EPEVER charge controllers. And today, we will be talking about iPower series high frequency sine wave inverters. So it's a high frequency sine wave inverter, and we aim to increase the general knowledge about inverters so that you will be able to better support your installations or your installers and your customers. Okay, so we will be talking about some principles of selecting an inverter, and then we will have a look at uh, yeah, the overview of the inverter itself, the exterior part, the interior part, the functions that it has, and something called power factor, which is really important while selecting an inverter. And finally, we will add some notes about uh, using and applying inverters. Okay, inverters greatly impact the overall performance of solar systems. We are aware of that. And there is a very famous sentence that says, don't judge a product by its package. This completely applies to inverters because you can almost distinguish nothing from an inverter's package. They all come in good looking interfaces, but there are lots of principles which need to be taken into consideration about these electronic devices. Okay, first is the absolutely the output power or continuous power rating. This is the amount of power you would expect to use continuously without the inverter overheating or shutting down. So this is the continuous power. And secondly, the surge power. And what is the surge power? You might already know about it. It is the additional power required to start some appliances. And once running, they may need considerably less power to keep functioning. The inverter must be able to hold this surge at least for a few seconds to start. So if we consider that this is the continuous power, this is the surge power that is required for starting of some appliances. TVs, refrigerators, and etc. are examples of items that require only relatively low power running, but require high surge power to start with. Inverters come with different output power waveforms. So the third principle is the power quality. The output voltage from an inverter might have several forms depending on the technology, the elements applied, and generally it can be either square wave, like the green one that you see here, uh, modified sine wave, the blue one, or pure sine wave, which is the red one. A modified sine wave inverter can adequately power some household appliances and power tools. It is cheaper, but may present certain problems with some loads such as computers, microwaves, ovens, and laser printers. Virtually all low-cost power inverters are modified sine wave. So whenever you see that, okay, the inverter price is really cheap, then the materials used to create the output are designed to give you some kind of square output. True sine wave inverters or digital inverters are designed to replicate and even improve the quality of utility companies. To operate higher end electronic equipment, a sine wave inverter is recommended. And regardless of the power quality, the protective functions are also very important while selecting inverters, because these devices are always prone to some damages. If they are really easy to get damaged, and the amount of protective function applied to inverter will determine the ease of installation and implementation in real appliances. Well, the first one is the frequency. Frequency is another principle while selecting an inverter. There are usually two types of inverters when it comes to frequency: the low frequency inverters and high frequency inverters. Simply, low frequency inverters use components with lower rates of switching, and this demands it to be larger and heavier. And in contrast with low frequency inverters, high frequency models typically switch at a frequency close to 50 kilohertz or higher, and thus allowing for a smaller, more efficient transformer and overall smaller package. And both of these inverters have their own applications based on their load type, and depending on the load surge power, you may need a different type. So low frequency inverters are capable of absorbing surge loads. As we discussed it in the second slide, these kind of inverters have a higher capacity for surge powers. They have larger and more robust field effect transistors or FETs that can operate cooler and can surge in high rates. However, for high frequency inverters, they typically surge at lower rates or for shorter periods of time than their low frequency counterparts. And high frequency inverter application is appropriate for smaller appliances like computers, and has a decreased capacity for long-term exposure to high surge loads. And high surge loads are motors, are pumps, or some high torque tools. And generally, there might not be a large difference between these two types of inverters considering the output quality or output efficiency, but the surge power determines which type of inverter these two inverters are you going to use. So it really depends on the load type that you are going to apply to your inverter. Okay, so a few principles left. Inverter efficiency is the ratio of the usable AC output power to the sum of the DC input power. So the higher the efficiency, the better. It's obvious. And connectivity is nowadays really important. So we always need to collect some data from the system parameters, and a good inverter should be capable of providing the data for your monitoring means by different means. Nowadays we have Bluetooth, Wi-Fi, or I don't know, the Internet of Things, and so on. So a system that you're using must be capable of providing you with data over some network, Modbus, HTTP, whatever. You have to get some data out of your system. And this is what we call the connectivity. And the price is absolutely one of the main factors to choose a product. So the lower, the better. We have some colleagues from sales department today at the webinar, so feel free to submit your sales related questions about the prices of the inverters, and they will be coming to you soon. Well, so now that we have introduced 8 principles of selecting the inverter, let's see how IPOWER series behave regarding these principles, how it ranks. Well, IPOWER ranges from 350 to 2 kilowatts, and the DC voltage can be 12, 24, 48. So it's a wide range you can apply with any battery system. It has both 110 and 220 volts AC output, and the surge power can be up to 3.2 kilowatts. And you will find lots of information about these kind of inverters and the data sheet. As you can see, the continuous power, for example, for IP2000 is is 1600, and it can surge up to 3.2 kilowatts, and the P15 or load output power for 15 minutes is 2000 watts or 2 kilowatts. So you will be able to check for all these information within an inverter's specification sheet. So beside the surge power, the quality of the provided power is completely a pure sine wave inverter with less harmonics. We will cover it. And it comes with a variety of protective functions in the input and output side. Let's have a look into them. So it is protected against over voltage and under voltage at the input side. Additionally, overload protection and short circuit protections are added to the output side of the inverter. And there are some LED indicators that reflect the status of inverter, and buzzer will start buzzing in some conditions such as input under voltage, as I mentioned, input over voltage, over temperature, or load short circuit, overload, output voltage abnormalities. And there is a complete list of these kind of faults in the manual, and you can have a look at them. And an important note is not to reverse the polarity of this device in the input size. So this device is not protected against battery reverse polarity. Otherwise, it will blow the fuses off. So the installers have to be careful about it. And the reason it doesn't have is that we have tried to keep the price, the cost reasonable enough to be competitive in the market. So we have inverters that come with reverse polarity protections. However, this one is designed to have the least cost and with a good quality to be applied to appliances. I forgot to tell that the overheat protection is also a feature of this inverter, and we will be covering it in next slides. Well, regarding the frequency, as I told, it's a kind of high frequency inverter, and the efficiency can be up to 95%. Generally, the efficiency of these kind of inverters is over than 85%. Yeah, for higher powers, you will get higher efficiency, and we will see the diagram for that. This is how these family of products are named. So IP represents the iPower series. The 2000 is the 15-minute P15 output power, and this number here is the voltage, which stands for 12, 24, and 48, and it determines the inverter's working voltage in the input side. And for the output voltages also, you will have one or two based on the voltage that you require. And the output socket also is determined by MAET for different terminals, and U stands for USB output. Some of these inverters come with USB output, some do not, and this letter stands for that. And finally, some of inverters come with the Modbus communication with the RS485 communication port. So some of IP series have this connectivity and some not. And yeah, the interface is really simple. It's a lightweight inverter, like as many high frequency inverters in the market, and the installation is straightforward. We will be looking at it. This is the overview of the front side and the back side of the inverter. You get the DC voltage here, and you get the AC voltage at the output. You have two terminals, and you will be connecting the positive and negative poles of the battery to the inverter at the input side, and then you will be getting the AC output here, and this is the power, and you can turn the power on and off with using this button. and it comes with a deep switch which helps you change the frequency and voltage in the output. And some models comes with USB output, and you can use it for charging your mobile. And finally, this is the RS-485 communication port, which you will be using to communicate with the inverter. This provides a better overview of the power switch functions. So as you know, these are the dip switches. Dip switches are manual electrical switches, as you can see here. They're used to customize the behavior of an electrical device for specific situations. For example, here we use them to switch the output voltage and the output frequency. And well, depending on what is the status of this switch, the output will be different. It is recommended to stop the inverter before making any changes to these switches, otherwise it might get damaged. So always turn the inverter off and then try making changes on the deep switches. So iPower works with MT75, and MT75 can display the AC output and its parameters. So it's a kind of display unit, and it can control the AC output also with the help of a charge controller, and you will be supervising the battery voltage, and in certain circumstances you can have this module turn on or off your inverter based on your protective functions that you define. And sometimes some loads are connected, for example, directly to the battery, so it consumes the battery power directly. And in this occasion, to protect the batteries from deep discharge, we need to continuously measure the battery voltage and make a control over it. And the switch on iPower must be changed to external switch connection in order to be able to remotely turn it on or off. And this is something that you can tell the sales team that you want this option, and they will make this customization for you. So as another example, working with Triron, this is another charge controller series of EPEVER with ES2 and RCM modules. And the Triron can display even the AC parameters of the inverter. So if you connect your inverter to the charge controller, you will be able to read the parameters of your inverter, I mean the AC side, right there in your charge controller's screen, which is a nice feature, I think. And just we have to keep in mind that some models do not have RS-485 communication, and the switch on iPower must be changed to external switch in order to do that. As another example, it can work with tracer 50 to 100 amperes to control the inverter. So this is the tracer series iCurrent, and yeah, they can work up to 100 ampere capacity, and they are parallelable, so you can connect them in parallel together up to 8 charge controllers, and this will help you increase the capacity of your off-grid system. And at the same time, the tracer AN can turn on or off your inverter automatically according to the parameters that you set to the charge controller. And I will introduce you what are those parameters. What you see here is an overview of what's inside our inverters. Basically, iPower PCB can be divided in 4 main parts, and the whole procedure is to take a DC input right here and deliver the AC output at this point. Well, so at part 1, the DC voltage is turned to alternating voltage after passing it. So how it is done? It is being done by switching, and some switches provide the AC outputs here in the positive and negative side for us. And on the other hand, the push-pull booster boosts up this kind of AC voltage so that it is ready to be rectified which takes place in the next part. And there are some MOSFETs, as you can see, and some fuses here, heating elements or heating components are bolted onto a heat sink here for thermal cooling. And iPower has really a good thermal design. And here are some capacitors, a transformer, a heat sink, and input cables, and so on. So this part takes care of converting the DC input to an AC output. At part two, there is a high voltage rectifier, and it is for boosting the voltage and preparing it for pulse width modulation. In part three and part four, the control signal to prepare the pure AC output is provided. So SPWM technology is hired to generate the switching signals at these parts, and sinusoidal pulse width modulations, or SPWM technology, is a popular control method widely used in power inverters, and it has advantages like switching losses, and the output has fewer harmonics. And SPWM tries to make use of many triangular switchings and many triangular signals that are level shifted or phase shifted. The duration is changing, the frequency is changing of the pulses, and then the output is compared with a single sine wave output to finally generate what we call the pure sine wave waveform at the output. So the process is being managed by half-bridge DC to AC step-down converters to generate an output sine wave. So after looking at the inverter's interior and exterior parts, now uh, let's have a look at this diagram. This is a very common diagram of every off-grid system. So you will find the solar panels here. You will find your batteries, the fuse or the switches that you use between the charge controller and your battery, the battery temperature sensor, which is really essential in off-grid system, the breakers that you put between the inverter and your batteries, the inverter itself, your DC loads that are connected directly to the charge controller, and the AC loads that are connected via a switch to your iPower. So we are trying to protect our system, right? We have a breaker here, we have a breaker here, breaker here. So off-grid systems really need to be careful and protected. And okay, for connectivity, iPower is capable of communicating with PC or mobile, and yeah, both are happening with via RS-485 port. And it should be noted that this is an option and should be mentioned while ordering the device. So input voltage, let's say here in the input side, we have the input voltage, the input current, and the power and the status. And at the output side, you will have the output voltage, output current, and power status, and the device temperature. So what I already mentioned can be all monitored via RS-485 port and within the software. And you have some configurable parameters via the software, and this is the over voltage disconnect voltage, or over voltage reconnect voltage, or I don't know, low voltage disconnect voltage, and low voltage reconnect voltage. So according to the specifications of the batteries that you're using in your off-grid system, you have 4 parameters that you can set to efficiently protect your batteries from getting discharged or abused by high loads or high capacity inverters. So even if you have a high capacity inverter, you can manage these parameters in order to ensure the safety of your batteries. Well, here are some screenshots of PC software and the mobile application, and more information about installing and making use of the products could be found on our learning management system. So we have a learning management system. If you go to our website, you will find about it. and you will be getting to know how to install the software, how to use it, and how to apply it. On the other hand, you can find the softwares and applications needed, required in our website in the download part. Okay, now the efficiency of iPower series. As discussed in the previous slides, by efficiency, we can really say that what percentage of the power that goes into the inverter comes out as a usable AC output. And we all know that nothing is 100% efficient. And as you saw, there are multiple conversions. First it's converted to AC, then the DC, then rectified. Then with this PWM it goes into AC again. So naturally you will have some losses in your system because you are doing some conversion. This efficiency figure will vary according to how much power is being used at the time, and high efficiency comes generally with greater power usage. So if we draw a regression, draw a line to these points, we'll find out that there is a positive correlation between the power and the efficiency, and as the power increases, the efficiency also increases. So normally the efficiency of EPEVER iPower series are higher than 85%. However, they can reach up to 95, which is the maximum efficiency for IP2042. Of course, this is the efficiency that is reported in the temperature 2025 centigrades, and within different temperatures, you will expect different values for efficiency because it changes when the temperature change. And yeah, temperature always play an important role for off-grid systems. Inverters, like all of other semiconductor-based equipments, are sensitive to the heat, and in general, they operate best at cooler temperatures. So they also suffer from power losses and damages, and when the temperature goes high, these problems occur with the inverter. So as the inverter works to convert the DC power to AC power, it generates heat. It's natural, and this heat is added to the ambient temperature of inverter and its enclosure, and the inverter dissipates the heat through fans, or at least tries to dissipate, and the heat sinks help to dissipate this heat, but it's not always successful. The heat needs to stay below a certain level at which materials in the inverter will start to degrade. So what we call the protection against over temperature is if you have an increased temperature from a certain point on, the inverter will try to degrade the output power so that it will not be damaged by overheating. And in a certain temperature, it will completely shut down, and it will wait until the temperature comes back to a certain value. So this is the function that we call the temperature rating in inverter. And if you can see here, iPower series has really good thermal design. So this is a screenshot of the heat analysis of the components, and as you can see, the most warm part has 88 degrees, which is reasonable and acceptable for an inverter in this range of power. And well, what I want to finally mention is the power factor. So well, power factor is usually ignored in the design process. So power factor is a measure of how effectively you are using electricity. And there are three kinds of loads. Generally, there are three kinds of loads in your consumer list. They are either resistive loads, they are inductive, or they are capacitive. So if the load is for example, inductive or capacitive, then there will be a shift in the voltage and current phase of the load. So you can see there is a shift between the voltage waveform and the current waveform. And it's the same for the capacitor, but in the other side. And this is the source of waste. So if there is a lead or lag between these two signals, then you are losing some power. And in this situation, we say that the power factor is below 1. And if the power factor is less than 1, you have to supply more current to the load for a given amount of power. And yeah, so as you can see, capacitors have opposite effect and can compensate for the inductive effect. And that's the reason that some industrial sites or even some buildings have large banks of capacitors. That's the usage of capacitive bank. That's to bring the power factor up to 1 and while consuming the same power. And well, so even for an off-grid solar inverter, the power factor will be really important. Uh, in order to summarize it, if, for example, the power needed to power your consumers is P, and you have some reactive power which is originated by inductors or capacitors. So instead of P, you have to prepare the power S, which is the apparent power, and as you can see, is higher than and the P, and you are providing much power to power the same amount of usage. So you're losing some power, and you need to consider the power factor in your off-grid design. So what I want to tell you is that the power factor is not a principle that is related to inverter. It is only related to the consumers and to your loads, and you can calculate it before purchasing an inverter. So we have a safety factor when we are designing an off-grid system, and normally we do not put the inverter, in higher than 70% of its capacity. So to make sure that it will have a long life, we consider only 70% of its continuous power capacity, so that the lifetime would be insured for this inverter. And of course, if you have reactive power, you have to consider also within the 70%. Well, this is the last slide. So we have some notes here that says do not install the inverter in sealed places. It needs some kind of ventilation, and it's not recommended to install an inverter within an area that's not ventilated. And you have to install the fuses or circuit breakers, as I told you, in different places to ensure that the installation is safe. And you have to follow the range, the voltage range that you connect to the inverter. So usually there is a wide range for the input range. However, if you're out of that range, you might damage the inverter. And for some places, which is outdoor places, you need to install external arresters or air switches for outdoor using. And the surge protection is not included in this product. And yeah, so as I mentioned, we have a safety factor, and you have to keep the load power lower than the inverter constant power output. This helps you have a longer life with the inverter. Do not change output voltage and frequency when the inverter is running. When you're playing with the deep switches, you have to be careful about it. And this inverter is off-grid. So with that, thank you so much for your attention and for your being with us today.